Okay, so this is the next example in type 1 of partial fractions. So as you can see in this one, we have got 3 linear factors. So the process is the same. It's just going to take a little bit longer because there's an extra one to do. So start by setting up the partial fractions. So I'm going to need an a over x plus 1, a b over x plus 2, and then because I've got another one, I'm going to need a c over x minus 3. Okay, and if there was another one, x plus 4, you'd need a d over x plus 4. So it would just keep going on and on. You're unlikely, realistically, to get anything more than 3. Okay, now if we went through the motions of adding these 3 together, that would be our common denominator, and we would have to adapt the fractions. So we're going to make the numerators equal to each other. To get from here to here, we need to multiply by these 2 brackets. To get from here to here, we need to multiply by these 2 brackets. And then to get from here to here, we need to multiply by these 2 brackets. Okay, so it's the same process, this is just longer, that's all. Now we're going to substitute in. So let's start with minus 2. If I substitute minus 2 into here, that's going to become 0, so all of that will disappear. But that will also become 0, so all of that will disappear. So by substituting minus 2 in, I'm going to eliminate a and c, and that'll give me a chance to work out b. So if I substitute minus 2 in, this is 4. 3 times 4 is 12. Minus 14 is minus 2. Minus 8 is minus 10. Obviously, you can stick this in your calculator, but just make sure if you're squaring the minus 2 that you put brackets around the minus 2, otherwise it'll tell you it's negative. This is 0, so that's gone. This is 0, so that's gone. Minus 2 in here, minus 2 plus 1 is minus 1. Minus 2, take 3 is minus 5. Minus 1 times minus 5 is 5b, which means that b is minus 2. If I substitute x equals 3 in, this is going to eliminate a and b, and I'll be able to work out what c is. So 3 squared is 9, times 3 is 27, plus 21 is 48, take 8 is 40. This disappears, this disappears. 3 plus 1 is 4, 3 plus 2 is 5, 4 times 5 is 20, so that's 20c, which means c is 2. And finally, if I put minus 1 in, that's going to eliminate c and eliminate b. Minus 1 squared is 1, times 3 is 3, minus 7 is minus 4, minus 8 is minus 12. That disappears, that disappears. Minus 1 plus 2 is 1. Minus 1 take 3 is minus 4. 1 times minus 4 is minus 4a, which means a is 3. So we just need to finish it off by putting those numbers on top of the denominators. So we've got 3 over x plus 1 minus 2 over x plus 2 plus 2 over x minus 3. And that is now split into 3 partial fractions. Okay, the last one we're going to look at is this one. It's got two linear factors, but the linear factors haven't just got a 1x. So I'm going to show you an alternative approach to working out what A and B are. First part is the same. So we're going to say it's A over 4x minus 1 plus B over 2x plus 3. So that's the same. Next part is the same. We've got 2x plus 10. To get from here to here, we need to multiply by 2x plus 3. To get from here to here, we need to multiply by 4x minus 1. Okay. Now then, we can use substitution, which some students like. So if we were going to substitute to get rid of this bracket, I would need to substitute x equals minus 3 halves. That would lead me to work out what b is. And if I wanted to make this bracket be 0, I would substitute in 1/4, and that would lead me to work out what a is. Now that's perfectly fine if you're happy to use your calculator carefully to type in fractions, then that's perfectly fine, and that method will work perfectly well. Okay. Alternatively, this is as a second method, we can do what we call equate coefficients. Which some students prefer. So I'm just going to show you, and you can decide which method you want to do. You can equate coefficients all the time, you can substitute all the time, you can mix and match. So you could do a substitution if one was easy, and then equate coefficients if one was a bit tricky. So it doesn't matter what method you use, as long as you do it accurately, I suppose. Right, if we're going to equate coefficients, basically what I'm saying is, because this is, put an extra line and this is technically an identity, the coefficient, so remember the coefficient means the number in front of each term. So the coefficient of x, in this case, is 2. The coefficient of x on this side of the equals must be equal to the coefficient of x on that side of the equals. So if I equate the x coefficients, then on this side of the equals, there's 2 of them. On this side of the equals, well, here, we multiply that out, there's 2a lots of x there. So the coefficient of x is 2a. And here, the coefficient of x would be 4b, because if you expand that out, you get 4bx. So the 2a plus 4b must equal that 2 there. And if I divide both of those, everything by 2, I get that. Now if I equate the constants, well, on this side, there's 10. And on this side of the line, there is 3a, that's a constant, plus, or should I say, minus b. Now you can see that we have simultaneous equations which we can solve. So if I say here that a is 1 minus 2b, then I can substitute that into there. So 10 is going to equal 3 lots of 1 minus 2b minus b. So 10 equals 3 minus 6b minus b. That's minus 7b. Take off the 3 gives me 7. So 7 equals minus 7b, which means that b equals minus 1. And if I pop that back into here, then that means that a is going to be 3. Okay, so then we just have to go up here because I've run out of room. Put that back, our numbers back on here. So our final answer is going to be 3 over 4x minus 1 minus 1 over 2x plus 3. Okay, so that's just an alternative approach if substituting a number is awkward. Okay, but you don't have to use it. If you're happy to just stick fractions in your calculator, then you carry on and do that. Okay, but I will, on the next couple of videos, be using both methods at some point. Okay, that's the end of type 1. You should be able to have a go at exercise 1D now.